Greetings and welcome. This is Dr. V.D. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the definitions and terminologies in friction model. Let us begin the session. The first definition would be, what is friction? We have discussed regarding the friction that it is a phenomenon where when the two bodies are in contact and they are trying to slide one over the other, then a resistance will be seen in the phenomenon where this resistance is treated as the friction. So the definition says, in the phenomenon where two bodies are in contact and an effort to move one body over the other is resisted, friction is said to be prevailing in the system. This resistance to motion is called friction. As you can understand, let us consider two bodies which are in contact in this fashion. And this is the area where the both bodies are in contact. Right? This is the part where the both bodies are in contact. In this scenario, we can say that the lower surface, which is this one, the lower surface of the upper body and the upper surface, this one, the upper surface of the lower body are in contact with each other for certain area. In this particular example, they are in contact to certain area. When we try to apply some force to the upper body, generally what it should do, this upper body, let us say this as A, should move towards right side. It should move towards right hand side direction. But it will only happen when this area which is in contact is releasing, or we can say the surfaces gets released from one another, then only the movement will happen. Right? And why these surfaces will not get released easily? Because the uneven surfaces of both the bodies, uneven surfaces of both the bodies, which we call it as the crest centers of the surfaces, they get interlocked. Okay, when we see it in magnification way, we can say that they get interlocked and they will resist the motion. When you try to apply the force on one body, because of this interlocking condition which is happening, the motion will be resisted. And that resistance of motion is termed as the friction, and it is treated as a force. The frictional force which is prevailing in the system because of the interlocking of the surfaces, crest centers. Unevenness, we can say. Right? So, and that friction will depend on the area, the body condition, and the contacting surfaces condition. Depending on all these criteria, the frictional force value will be dependent. So, the magnitude of frictional force will increase as the force which is going to be applied on the body increases. And once it reaches the limiting friction, then the body will tend to move and the body will slide over the other body. So the definition says, in the phenomenon where two bodies are in contact and an effort to move one body over the other is resisted, friction is said to be prevailing in the system. This resistance is called as the friction. Next one is, define coefficient of friction. This is the ratio which we are going to see now. The definition says, the coefficient of friction is a value that shows the relationship between the force of friction between two objects and the normal reaction between the objects that are involved. Right? So, as per the definition, let us take one example here. a body is placed on the ground. Let us say this is the ground. Body is placed on the ground and we are applying a force of F towards right hand side direction. The body is in contact with the floor here, right? So this is the area where the body is in contact with the floor. Then we know that when the force is being applied towards right hand side direction, the body will try to move towards right hand side direction. Here at this place where the body is in contact with the floor, the frictional force will be prevailing. And we all know that the resistance, the frictional force is a resistance. That means the force will be in the opposite direction to the movement of the object. Okay, so as the body will try to move towards right hand side direction, here the frictional force will be acting towards the left hand side direction, right? And we all know as the surface is being removed, the contacting surface, the floor is being removed, then what we have to show? We have to show the reaction at that contact point. So that reaction would be the normal reaction and it will be directed towards the object. It will be directed towards the object. So this is the normal reaction and this is the frictional force. Now coming to the coefficient of friction. The coefficient of friction is denoted by the letter mu and it is the ratio of the frictional force to the normal reaction. This is the equation of the coefficient of friction. And in many problems, all the problems where you are going to see the friction phenomenon, there you will be given the magnitude of the friction or the normal reaction in the terms of the coefficient of friction. So that clue, it lies between 0 to 1. And it lies between 0 to 1. So in this way, the coefficient of friction definition is given, which is the ratio of frictional force applied or prevailing in the system to the normal reaction. Now let us see the next definition. What is dry friction? We have seen so many cases while solving the problems, the different types of frictions like dry friction and fluid friction, where the bodies which are solids and if there is no lubrication prevailing, then between the contacting surfaces, then that sort of a friction is called as the dry friction. And when some lubrication or any fluids are being present, contacting in the body, in between the two layers of the body, some layer of fluid is being present, then that is treated as the fluid friction that we will come to know. First, let us see what is dry friction. So the definition says the friction that exists between perfectly cleaned and dry solid surfaces is called dry friction, right? So there should not be any fluids present in between the contacting surfaces of the bodies. Two bodies should be in contact with each other and these two surfaces which are in contact should be perfectly clean, and these two bodies which are in contact with each other, which apply the resistance one over the other, is treated as the dry friction, right? So the definition says the friction that exists between perfectly cleaned and dry solid surfaces is called dry friction. Next one is, what is fluid friction? Now coming to the criteria of fluid, we have already discussed that fluid is nothing but a state of matter in liquid and gaseous. So all the liquid state matter and the gaseous state matter are considered as the fluids. The best example which we have considered while discussing this friction details or friction module is the aeroplane or the plane which is flying in the sky. The air forms as the fluid resistance for the movement of the plane. When we overcome this fluid resistance, the air resistance, then the aeroplane will move from one point to the other. As well, the liquid resistance we have seen, that is the ship or a boat which is traveling in a sea or a ocean, where the boat's solid body is in contact with the water. So water will resist the movement of the object, that is the boat, and this boat will try to move forward in the water when it will overcome the friction that is being acted upon by the water onto the contacting surface of the boat. So that is the fluid friction, where fluids are nothing but air and the water, or else we can say liquids and gases. So the definition says the thick layer of oil lubricant is introduced between two surfaces in contact. The friction between surfaces are separated by a film of lubricant is called fluid friction. Right? So in the definition it has been given as the lubricant or lubrication, where the lubrication is being seen in the form of the oil, some sort of oil. The best example would be the lubrication oil which you are going to use in your engines of vehicles, maybe car, bikes and all, where the lubrication will form a thin layer of between the two contacting surfaces or the mating parts, and the sliding of one part over the other becomes very easier. So that is treated as the fluid friction. So the definition says the thick layer of oil lubricant is introduced between two surfaces in contact. The friction between surfaces are separated by a film of lubricant is called fluid friction. Coming to next one, define non-viscous friction. The definition says the thin layer of lubricant is allowed to prevent the direct contact between surfaces and reduces the friction. The friction that exists between the surfaces is called non-viscous friction. Non-viscous friction. So the very thin layer that is being provided in between the two mating parts or two objects in contact, there the viscosity will be very less, or we can say the friction which is prevailing is treated as the non-viscous friction. Next one is, what is limiting friction? So as we have discussed, the limiting friction, the graphical representation we have seen like this. If we consider the application of force, in this fashion, for overcoming the friction, we need to apply a direct force, and this force will be directly proportional to the friction. Whatever friction that is being acted between the contacting surfaces, that is directly proportional to the force that is being applied. And this force, which is applied in a static condition, the force which is being applied to move the body in a static condition, at that time the frictional force is directly proportional to the force applied. And at one point the force which is applied is sufficient to overcome that static friction. That means the very next moment the object will move. So that force will be higher. The maximum force which is being applied for moving the object, that point is called as the limiting friction. After this limiting friction condition, the object will start to move, right? Once the object starts to move, the status is called as the dynamic friction. Here it is called as the static condition, and this is the condition in the dynamic form. We can call it as dynamic friction. That means the friction that is being prevailed when the object is moving. So after this limiting friction condition, the object will start to move, and the lesser force is needed for the object to move continuously. And at one point, some friction, the force is sufficient. Some little force is sufficient than the limiting friction condition for continuously moving the object. So this is the case where the limiting friction is seen. Limiting friction is the condition where after the limiting friction point, the object starts to move, or we can say that The point where the object will tend to move is called as the limiting friction. It is the maximum applied force in the static condition of the two bodies in contact. So let us see the definition. The maximum friction that can be generated between two static surfaces in contact with each other is called limiting friction. So that is the maximum point, the maximum force which we are going to apply onto the object for the object to move. Once the object starts to move, that means the interlocking of the uneven surfaces gets released. Little force is sufficient. That means the less force that is being applied is sufficient for the object to move continuously. Hence, the interlocking will not happen that easily once the object starts to move. So, the object can be slided easily. So, this is the definition which is given. The maximum friction that can be generated between two static surfaces in contact with each other is called limiting friction. Coming to next one. Define angle of friction. So the definition says the angle between the resultant reaction and the normal reaction at limiting condition is called as the angle of friction, and it is denoted by the Greek letter phi. Right? So this is the definition. Let us understand with using figure here. The representation of the frictional force and normal reaction, and this is the resultant reaction, that all are acting in the directions as shown here. So as you can see, the frictional force which is acting towards left side in this particular example, and the normal reaction which is acting towards the object. Between these two, the resultant reaction which is shown here. This resultant reaction is defined again as the reaction of or the resultant of the frictional force and the normal reaction. The resultant reaction is defined as the resultant of frictional force and the normal reaction. And the angle between this normal reaction and the resultant reaction is treated as the angle of friction. It is treated as the angle of friction. So if you draw a triangle, right angle triangle, as shown here, representing the normal reaction, the frictional force and the resultant reaction, the inclination between the normal reaction and the resultant reaction is called as the angle of friction, and it is denoted by the Greek letter phi. So here you can observe it is given as tan phi. From the right angle triangle you can directly get, if you apply the tan angle, the tangent, if you apply, tan phi is equal to F by N, that is frictional force opposite by adjacent, and we know that the ratio of frictional force and the normal reaction is the coefficient of friction, that is mu. Hence, tan phi can be treated as mu, coefficient of friction. So, the coefficient of friction value mu can also be given in the form of angle of friction, which is tan phi. So, this is the definition of the angle of friction, which is given as the angle between the resultant reaction and the normal reaction at limiting condition is called as angle of friction, and it is denoted by the letter phi. Coming to next one. What is angle of repose? So, angle of repose is defined as the minimum angle of an inclined plane which causes an object to slide down the plane. So, here we can observe that when an object is being present, or we can say when the object is placed on an inclined plane, where there if the inclination is not sufficient for the object to slide, that is because of the friction that is been prevailing, the object is not going to slide down. And at a point when we increase the angle, then the object by itself will tend to slide downwards. You can understand this using this figure given. Here, this is the object which is placed on an inclined plane, and the weight of the object is given as W, which is acting vertically downwards. Let us say that plane on which the object is placed is at an inclination to the ground, at an inclination to the horizontal. Now, in this state, the object is not moving anywhere because of the friction that is prevailing, and even though the weight of W is acting vertically downwards, the object is not moving anywhere. When you try to increase the inclination of the plane, at some point, this object, at some inclination, as the inclination is being increased, at some point, this object will try to slide down by itself without any external force that is being applied. The object will slide down on its own. That inclination where the object will start to move downwards by its own is treated as the angle of repose. It is treated as the angle of repose. So here in this condition, theta is that angle of repose. And the definition says, angle of repose is defined as the minimum angle of an inclined plane which causes an object to slide down the plane. Coming to next one. What do you understand by static friction? Right? What do you understand by static friction? The definition is given as, in static friction, the force applied to the body is not sufficient to move the body, and the friction acting in the system is called static friction. Right? Let us say on a surface a body is placed. In the previous definition we have seen, in the definition of the limiting friction, we have seen the graphical representation of the force and the friction, and we have seen the static condition and the dynamic condition. Let us first see here what is static friction. A body of weight W is being placed on a floor or on the ground, and a force of F is being acted. Let us take an example here that because of the weight W of the body which is placed on the floor, and it is a rough floor. Let us say it is a rough floor. That means friction is acting here. This body will move only if 500 Newton force is being applied onto. Let us say if F is equal to 500 Newtons, then only the body will start to move. Let us consider that. It's an example. Let us consider that if a force of 500 Newtons is applied onto the body, then only the body will start to move. Now what we are doing, we are not knowing that. We don't know that we need to apply 500 Newtons of force. Initially, we are considering that we don't know how much force is needed for the object to start to move. And we have applied only 100 Newton force here. First, we are applying only 100 Newton force. Will the body start to move? No. Why? Because of this weight of W, we need 500 Newtons of force for object to move. But we don't know that. We have applied 100 Newton force. Will the body move? No. What we can say here, the friction is being prevailed, and even though we are applying a force of 100 Newtons, the body is not moving. If the body is not moving, does that mean that we are not applying any force? No, we are applying a force. We are applying a force of 100 Newtons here. But it is not sufficient. It is not sufficient for the object to move. So that represents that when you apply the force of 100 Newtons, Here, the frictional resistance that is created, between the contact surfaces is also 100 newtons. The frictional resistance is also 100 newtons. But this 100 newtons force is equal to the frictional resistance and the object is not moving. Isn't it? So that movement of the rigid body which is not being moved is the condition called as the static friction, and this static friction is 100 newtons. So static is the condition where the objects are not moving anywhere. Even though the object is not moving, it doesn't mean that we are not applying any force. We are applying the force, but it is not sufficient. That is the case. Now let us say a force of 200 newtons is being applied. A force of 200 newtons is being applied. Then again the frictional force will also be 200 newtons. Again the frictional force will also be 200 newtons. Why? Because whatever force we are applying on the object, the exact magnitude will be reflected in the static condition in the opposite direction. So now when you are applying 200 newtons, will the object move? No. Again, the 200 newton force is not sufficient for the object to move. It doesn't mean that we are not applying any force. So we are applying 200 newton force and the frictional force is also 200 newtons. So it is directly proportional. In static condition, whatever force you are applying, the friction and the force, if you take a graphical representation, it is a linear direct implementation. In static condition, whatever force you will apply, the frictional value would be that much. Okay, so it is a direct representation. And also, when you apply 400 newtons, or let us say when you apply 499 newtons, 499 newtons. Here also the frictional value would be 499 newtons. But will the object move? No. There is a 1 Newton difference. This is the physical practical example which we are considering, physical example, to understand what the static friction is. Okay. So this 499 Newton again is directly proportional. So in the system, the 499 newtons we are acting, or we are applying a force of 499 newtons, and the frictional value would also be 499 newtons. But even though we are applying 499 newtons, it is not sufficient for the object to move. Maybe it is ready to move. But it is not sufficient to completely start motion. Now when you apply a force of 500 newtons, then the object will start to move. At that condition, the frictional force will not be equal to 500 because the object has already started to move. And this 500 Newton force condition is called as the limiting friction condition. So in that limiting friction condition, once the magnitude of the force that is being applied is slightly higher, when we apply some greater force than the limiting friction condition, then the object will start to move. Once the object starts to move, then also the friction will be prevailing, but it will be less than the static friction condition. Only maybe 350 newtons or 400 newtons of force is sufficient for the object to move continuously. So that is the case. So there is a slight difference between the dynamic friction and the static friction. The friction that is prevailing when the object is not moving anywhere is treated as the static friction. And when the friction that is prevailing when the object is moving, it is the dynamic friction. Okay. So this is the difference. So once again let us see the definition. In static friction, the force applied to the body is not sufficient to move the body, and the friction acting in the system is called static friction. Now let us see the next one. Describe kinetic friction. Here the definition says, as we have discussed just now, kinetic friction is nothing but the dynamic friction. That means when the object is moving, then the friction that is prevailing is treated as the kinetic friction or dynamic friction. So definition says, the friction acting on a body which is actually in motion. Friction acting on a body which is actually in motion is called kinetic friction. Is called kinetic friction. Coming to next one. Describe ladder friction. So ladder is one of the application of the friction where we are going to see it, and it is very important for the friction to be prevailing on the ladder because it is like a linear application. It is like a linear object which is being placed against a wall and on the floor. So without the friction, the ladder cannot withstand and we cannot climb the ladder, right? So this would be one of the important applications of the friction, which is the ladder friction. So the definition says, the friction prevailing between the contact point of ladder legs, floor and wall, right? So when the ladder is being placed against the wall, the friction that is being acting here would be at the contact points. If you see, let us consider this is the wall and this is the floor, and a ladder is being placed here like this. A ladder is being placed here like this, and the ladder's representation is given as A and B. Okay, A and B. A and B are the two contact points of the ladder with the floor as well as the wall. And the weight of the ladder will also be considered, will be acting vertically downwards. And if at all any person is standing on the ladder or climbing the ladder, then his weight will also be considered. Weight of man. Let us say the point of the point where the man is standing is here. Then the weight of man will also be considered. Now at these contact points of A and B, there will be friction that is prevailing in the system. Or else, if the friction is not present, then the ladder will not withstand there. There should be some opposite force to the movement or sliding of the ladder, then only the ladder will stand there, right? If there is no friction at A and B, there should be some means. Maybe it is tied to the wall in this fashion at point C, then only the ladder will not slide down. Such kind of situation will be seen. But for the ladder to withstand without any tying up with the string or any obstruction, then it should the friction should be prevailing at A and B, the contact points of the ladder with the floor and the wall. Here you can observe it is a general common sense that the ladder will at point A will try to move towards left side. So here we can show the frictional force that is acting towards the right side direction, and we can write it as FA, and the normal reaction at point A would be an A towards the ladder application or towards the ladder. At point B, we know that the movement of the ladder will happen towards downward direction. So here we can say that the frictional force will be acting towards the upward direction, because always the frictional force will be acting in the opposite direction to the movement of the object. So here the frictional force will be shown as FB, and the normal reaction would be towards the object itself, that is ladder itself, and that would be NB. So this is the case, the ladder's example, where the frictional force and the normal reactions or the friction that is being acted at the contact points of the ladder will be treated as the application of the friction, and the ladder friction can be represented this way. So the friction prevailing between the contact point of ladder legs, floor and wall is the ladder friction. Next one is describe wedge friction. We have seen that the wedge is nothing but a triangular shape, a wedge shaped object, nothing but having a cross section of a triangle or trapezium. So the definition says the friction prevailing between the contact surface of any type of wedge shaped object and other bodies. It is the wedge friction. So we can see here the wedge, this would be called as the wedge. The shape is called as the wedge shape. Right? If at all the cross section is triangle, it is also possible that the shape, the cross section will also be a trapezium. In this way, you can say that the cross section will also be a trapezium. This is also a wedge. So both cases are possible, and the contact surface would be this surface and the opposite surface where the wedge shaped object is in contact with the body, and these wedges will be very helpful for it can be, these can be used as a tool for splitting the object, like the best example would be your axe, right? The axe which is used to cut down the trees or something, the branches or something. The shape is similar to the triangular cross section. Hence, these wedges will be very helpful for splitting the objects and to lift very heavy loads, to a little distance, to smaller heights. Okay, so these are the wedge shaped objects, or these wedges will be very helpful in splitting the objects or lifting very heavy loads to certain small heights. So the friction prevailing between the contact surface of any type of wedge shaped object and other bodies. Next one is, what do you understand by cone of friction? So in the figure itself you can see it is defined as an imaginary cone generated by revolving the resultant reaction about the normal reaction. So we have already seen what the resultant reaction is. It is the resultant of the frictional force and the normal reaction, and the angle is called, the phi angle is called as the angle of friction. If this resultant reaction is being revolved around this normal reaction in this fashion, then we can say there is an imaginary cone that is being formed here like this. This imaginary cone is treated as the cone of friction. Next one is, what is a wedge? So the wedge is a piece of metal or wood with triangular or trapezoidal cross section, as we have just discussed about the wedge friction. So wedge is the piece of metal or wood with triangular or trapezoidal cross section. Next one is, what is the principle of a screw jack? So the principle is, very large masses can be raised or lowered by pushing them up or down inclined plane having a shallow gradient. We have already discussed what a screw jack is. It's a screw which is being acted upon the nut, right? The screw, or we can say the bolt type of a part which is being rotating inside a nut, it will move up and down depending on our requirement. If the load is being lifted, if we need to lift a load, then we will rotate the screw in one direction, and this can be treated as the total load of W is sliding upon the inclined plane. Where the object will be moving up the plane. Then if we need to lower the load, we can treat it as the screw's inclination as the inclined plane, where the weight will be sliding down the inclined plane. So very large masses can be raised or lowered by pushing them up or down inclined plane having a shallow gradient. Next one is, define the efficiency of a screw jack. The efficiency of the screw jack is defined as the ratio of work done on load, which is W, in one revolution to the work done by the effort, that is P, in one revolution. So the representation is given like this. Efficiency is equal to W into P by P into pi d, where the effort is P here, then work done on the load, where small p here is the pitch of the screw and d is the diameter of the total screw. Then work done on the load by work done by the effort is the ratio of the efficiency, and it is given as, the representation is, efficiency is equal to tan alpha by tan alpha plus phi. Coming to next one. What is the condition for maximum efficiency of a screw jack? When alpha is equal to 45 degrees minus 5 by 2, then efficiency will be maximum. We have just now seen the efficiency equation, and in this case the efficiency is maximum when alpha is equal to 45 degrees minus 5 by 2. Hence the maximum efficiency can be given as 1 minus sin phi by 1 plus sin phi. The next one would be, what is overhauling of a screw? Now, if alpha is greater than phi, then the load will start to move downwards without the application of any torque. Such condition is known as the overhauling of screw. As we have seen the angle of repose, with that angle the object will try to move downwards by itself. Right? So, we are wantedly increasing the inclination of the plane. Here, this is the condition, the overhauling of the screw is the condition where if alpha is greater than phi, then the load will start to move downwards without the application of any torque. Such condition is known as overhauling of screw. Next one is, what is self-locking of screw? So definition says, if alpha is less than phi, the load is sustained. So here, this is the case which we need in the application of screw jack. The screw's inclination should be alpha, which it should be less than phi, that is the friction angle. Then only the load will be sustained there, or else the load will slide down on its own, which is not required in this case. Hence, that is, the load does not move downwards by itself. Such condition is known as self-locking. And next one is, what are the conditions for overhauling and self-locking of screw? If efficiency is greater than 50, overhauling of screw occurs, and if efficiency is less than 50, then self-locking of screw occurs. This is regarding the definitions and terminologies in friction module. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.